Hey everyone, so I really hope that you all are doing very well, and basically we will start by solving GATE question paper 2010. We are starting from the year of 2010 because whenever you give the GATE exam, obviously you have to study a lot of syllabus which has been taught in the 4-year planning or the 5-year architecture course, but having a really deep understanding and information about the last minimum of 10 years question paper also helps a lot. This is also what has helped me when I was given my exams, because I had only studied the previous year questions, but I had studied them thoroughly so that in one question I also understand what if one option was correct, why are the rest of the three options not correct. So basically that is what I will be also explaining to you people. And we start with GATE question paper 2010, starting from basic architecture MCQ, which were like question number 1 to question number 25, and these were all 1 mark each questions. I'll be basically solving the questions in the copy, and I have the question paper with me. I won't be writing the questions because it will be a very long video, as then I will attach the link of the question papers of the respective years which I'll be solving. And what I really want you people to do, that you just open the question paper or just take a printout. If you have a PDF of the, if you have a soft copy, basically just take a printout and solve it with me, because when you see the video and when you make notes accordingly at the same time, it will really help you because you're understanding at the same time. And then you can just pause the video. If you want to get more clarity, you can go and search on the internet if you want to search up for something. So we'll just start with the first question, which is natural granite, which is used for cladding in buildings, belongs to the category of dash: A, igneous rock; B, acid rock; C, sedimentary rock; or D, metamorphic rock. So basically natural granite belongs to the category of igneous rocks, but you also have the rest of the three options, and we need to understand the three options as well. So igneous rock, I'll just write a basic definition. We have all studied this in geography in our schools also. Igneous rocks is basically when hot molten rock or magma as it is called, so when this crystallizes and solidifies, it forms igneous rocks. And basically there are some of the materials in igneous rocks like granite. You also have basalt, which is also used in many of the foundations and road stones. You'll also read about basalt in the the history of architecture. Basically many of the Indian temples, Indian historic sites are also made of basalt. And gabbro, one more thing is there, gabbro. It's not very famous, so it's just better to know about it. And igneous rocks also actually have a very high crushing strength. Now coming to the rest of the options, acid rock is not a very acid rock is not actually a type of natural rock. It's actually a chemical element basically, so it's not a type of rock, and it's just given to confuse the people. So there are certain options which also will confuse you. So the next option was the sedimentary rocks. And these are basically formed by the deposition of mineral organic particles. And as we had igneous rocks examples, we also have sedimentary rock examples of the rocks that are used actually in construction industry. So you have sandstone, you also have limestone, shale, and also quartz. So these are all names that we are pretty familiar with. Limestone, for example, is used in making cement and building stones. Stones quartz is used in uh, glass making industries. And then we have metamorphic rocks. So these basically are rocks which are transformed under high heat and pressure. An example of metamorphic rocks is marble, which is obviously used in the construction industry. The second question which we come across is flying buttress is an architectural element of A. Indian architecture, B. Greek architecture, C. Gothic architecture, or D. Byzantine architecture. So basically, flying buttress, we see this in Gothic architecture. And this is basically a support system. So in Gothic architecture we have very high walls, we have usually very high buildings, and to just support them we have a certain structure like this, and this is basically called as the flying buttresses. And so this is a very important, very distinguishable feature of Gothic architecture. But coming to the other points also, like coming to the Greek architecture, okay, so what is the distinguishing feature of Greek architecture? It's basically, when we study about Greek architecture, we study about the columns. So columns played a very big role. So there were obviously the three types of columns. There were simple Doric, then a bit of decorative Ionic, and the highly decorative Corinthian. So these were all columns. And coming to Byzantine architecture, these were the structures in Byzantine architecture were highly decorative, and marble columns were there. Marble columns, highly decorative these were, and inlaid stone pavements and etc. Now, one more option is that is the Indian architecture, but Indian architecture as such is not like it's an amalgamation of different architecture. It has Indo-Saracenic architecture, Indo-Islamic architecture. So it's not one specific element of Indian architecture that we can identify. So this concludes this second question. The third question is, a major hole in the ozone layer has been identified above the A. Amazon forest, B. Arctic region, C. Savanna grasslands, and D. Sahara desert. So the ozone layer, the ozone hole basically, the ozone layer hole, which is caused due to the use of CFCs, chlorofluorocarbons, which were present in our refrigerators, in our deodorants, many of our perfumes, which have now been banned. But it has caused a very deeply climatic condition, which is a ozone layer hole, and this is basically in the Arctic region. And coming to the layers of the atmosphere, this is present in the lower stratosphere. Ozone layer obviously is protected, it just protects us from the harsh UV rays of the sunlight, and these rays can also cause skin cancer. So ozone layer is very important, and this has been depleted, and now it's being reconstructed. Now many processes are being done so that we can get the ozone layer to be complete again. Now, the fourth question is, a flat arch at the skew back should not have an angle less than 30 degree, 45 degree, 60 degree, or 90 degree. So basically, a flat arch. So if this is your arch, the flat arch, you will see that there is no curvilinear motions. These are all arches. and basically this part is called the skew back. Let me just change. This line is called the skew back, and here the it's a bit slanting. So basically this is how a flat arch looks, and so the question is asking at the skew back, this angle, this angle should not be less than what? So this angle should not be less than 60 degree, should not be less than 60 degree. And also a few of the points at flat arch is only used for light loads. So it is used for light loads. You'll also have lots of questions related to arts and the elements, and basically their elements, and like the keystone, visors, intrados, extrados, everything. So you have to know a little bit in detail about it. And also the span of the flat arc is only going to be around 1.5 meter for light loads, and for 1.5 meter the span. Now coming to the next question. The question states primary colors of natural light. Primary colors of natural light. So this is not to be confused by the primary colors that we have studied in the color wheel. The answer to this primary colors of the natural light are red, green and blue, and the primary colors in the color wheel is red, yellow and blue. So don't get confused. The natural light or color wheel also comes, so you have to know about that also. Going forward to question number 6, it states that horizontal member of a shutter that subdivides a window is termed as dash: A. mullion, B. transom, C. reveal and D. purlin. So basically what is it asking of the horizontal member? Horizontal member which divides the window. Horizontal member dividing the window. So this is termed as transom. So basically if this is your window, this is like the upper shutter and this is the lower shutter. So this area is basically this transom. And coming forward to the next options, first option we have mullion. So what is mullion? Mullion is basically when you have a window like this, so basically the vertical division in between the windows is called mullion. So this is also important because questions sometimes also come as if transom is to horizontal, then what is to vertical. So you have to remember these terms also. Coming to the next option, reveal. Reveal is basically the whole of the timber surrounding the window. So the length of the timber, like you have a window, you have the window and the whole of the timber which basically surrounds. So the length, this length is termed as reveal. The length of the timber. And coming to the next option, which is a purlin. So this is actually the structural member. The structural member used to hold glass, or used to hold the glass panels in place. Sorry. So this is basically, so we see that in one question only we get so many of information, and what happens in gate is that they won't repeat the exact question, so they won't ask what is the vertical member dividing the window, but they can, and they have asked questions like this. They can also ask something about reveal and purling, so we have to know about all these different options as well. To just know about the question better will help us in understanding the syllabus and understanding everything better. The next question we have is that if the temperature of a composite bar made of copper and steel is raised, so copper and steel is used to make the bar and the temperature is raised, then what will happen to copper? So because when the temperature is raised, will it be under tension, under compression, under shear or torsion? So as expansion coefficient, copper has higher expansion coefficient coefficient than steel, and therefore it will be in tension when the temperature is raised. So it will be in tension when temperature is raised. When temperature goes higher, copper becomes in tension because as when compared to steel. Now question number 8. Now, this is a very simple question. This is just asking the full form of EIA. If you have had any EVS or environmental studies classes in your architecture or planning anywhere, you know that this is a very commonly asked question. So basically, this stands for environmental impact assessment. And basically we have studied about this, but I'll just give a short definition of this. That is, this is the basically of evaluating the process of evaluating the likely environmental impacts of a proposed project. And what are the the different aspects they have? The socio-economic impacts also it sees. So it's not just based on the environmental impacts. If you're making a structure in a village, and it will also see, will that structure or will that um, type of building or will that type of business is beneficial for the villages people, or if it's beneficial for the urban population only. So it sees socio-economic impacts, it also sees cultural impacts, and it also sees human and health impacts, which is very important. As we all know, heat islands and everything, so it becomes a very important aspect in that way. Let's see the next question. Okay, so question number 9 is a steel truss with parallel upper and lower chords and inclined connecting members forming series of equilateral triangles is known as dash. A. Bowstring truss, B. Warden truss, C. King post truss, and D. Scissors truss. So basically, whenever you're asked about the types of trusses or the different types of steel truss, you need to remember the diagrams also. So I'll just make a small quick diagram. Sorry. So bowstring truss, you have supports here, you have a straight line here, sorry, and you come here. So basically, in a bowstring truss, you can see that this is the shape of a bow. So you can understand this. Coming to warden truss, Warren trust is the like the simplest form of the trust that we actually study and that we basically understand mostly. It looks like well this sorry hmm. Warren trust. Then we come to king post trust. This is how a king post trust looks. This area is called king post. This area is called abutment. Just a small like just a small information about this thing. Yeah. And then we have scissors truss. So it looks like pair of scissors, like open scissors. Sorry. Mm. So this is basically scissor truss. And you just need to understand, you need to remember some of the diagrams, some of the things, because what the questions of 1 mark are usually easy. It just is a bit of sometimes it's written in a complicated manner or in a confusing manner, but it's actually very easy. So the question again states the steel truss with parallel upper and lower chords. So in the in the first part of the question you only understand that we are looking parallel upper and lower and upper chords. So obviously this is the only place where we have the parallel upper and lower chords and inclined connecting members forming a series of equilateral triangles. These are all equilateral triangles. So this question is referring to Warring truss. So things like that we need to understand the rest of the options also. So moving to next question. In water supply systems, the reflux valves allow water to flow in one direction only, in both directions, through air-locked joints or under only low pressure. So, reflux valves basically allow water to flow to flow only in one direction. We'll see about this in the later part also, where we have some basically in later years also there's a very detailed question that has come, so we'll see more in that also. And this is also known as non-return valve. Now going forward to the next question. In Islamic architecture, the circular dome was constructed over a square configuration through a gridiron coffered slab, pendentives and squinch arches, double barrel walls and jack arches, and horizontal cross tie members. So basically, um, the question has Islamic architecture, where obviously we see a dome, and this dome was constructed over a square configuration. So remember, if we are talking about this will come as pendentives and squinch arches. Pendentives is basically when a dome is placed on triangular. So this is how the support looks. and this is all on walls and columns. This is all. So basically this area, this support is termed as pendentives, this support. And when you put a dome over, like on a circular frame like structure, I would say, so like if it's a structure like this and it's placed basically like a square or a rectangle configuration, then this is called squinch arches. So basically we see this in Hagia Sophia as an example also. Yeah, so we see that in there. Next question, we have question number 12, and it states that with respect to energy conservation and cost efficiency, the nature of an ideal built form should be high rise low density, medium rise high density, low rise high density, or low rise low density. So we have energy conservation and cost efficiency. So this is basically a question for the ECBC, but it can be answered with the help of like a common sense also, because you have high rise, like for example you have high rise low density. So when you have high rise, that means that you will use lifts and elevators and certain electrical basically transportation help you will need high rise. So you will have lifts and stuff. And when we talking about high rise, it obviously the energy is not really conserved. It can be conserved, but the cost goes high. So this option is obviously not preferable. uh, Low rise high density. So when we talk about low rise high density, it means that the apartments, like for example apartments or houses, are not very high, but they are very close. They have a very close by density, very highly populated. So what will happen, obviously there will be less circulation of air, there will be less space for everyone. So this will obviously uh, make use of many energy appliances, energetical appliances you will use. So energy goes up, and then cost also as such goes up. And coming to low rise low density, so this will work because you have low rise and then you have low density, which means that there can be spaces. This is actually ECBC code, according to the ECBC code, but I'm also explaining it. For example, if you don't know the code or if you cannot remember it, so you can think about like this and you can figure out a way. So low rise low density, which means you can just imagine that the apartments or the residential complexes or basically built forms are separated, so free air circulation, ventilation is there. So energy is also conserved, and cost is also reduced because you don't need to use as much as appliances for heating and cooling. So question number 13 is actually an AutoCAD based question. AutoCAD based questions also used to come, like because we are obviously discussing 2010 paper, so that time AutoCAD based questions were coming also in lot in almost in every year. But right now it does not come in that much, but I will make a whole PPT about it, about the AutoCAD questions all in one PPT, so that it becomes easier just to just revise once. You can just see the PPT and then you can be okay. So question number 14, when shear stress exceeds the permissible limit in an RCC slab, then this problem is solved by how? So we can see that the shear stress exceeds in in a RCC slab. So when obviously we have we have stress increased, so stress increase, so how can we make the system stronger? So we will provide shear reinforcement. The options are also that we can solve this problem by increasing the slab depth, but when you increase the slab depth, obviously the stress will also increase, so that won't work using high strength steel. Not the question. We will only solve this problem by providing shear reinforcement. Question number 15 is an electrical numerical. So I will do it when I do the numerical part of this year's question. So we'll go to question number 16, and it states that prime resultant forces that develop in a structure due to an earthquake depend on A. Mass and surface area of structure, B. Surface area and stiffness of the structure, C. Stiffness and mass of the structure, or D. Surface area and volume of the structure. So basically, resultant forces developing due to earthquake. Due to an earthquake. So this will be based on stiffness and mass of structure. Also where the central point is located, the central mass and everything. So it's based on that basically. This is the theory part. It does not have to be explained that much. Okay, going to question number 17 now. Concept of serial vision has been applied to the approach layout of A. Victoria Memorial Complex, Kolkata, B. Umaid Bhavan Palace, Jodhpur, C. Vidhan Sabha Precinct, Bangalore, or D. Rashtrapati Bhavan Complex, New Delhi. So this is, you have to also remember that Rashtrapati Bhavan is being reconstructed. So I don't know the details if it would still follow the serial vision principle, but for this question, uh, basically serial vision had a very big example in Rashtrapati Bhavan Complex, New Delhi. And I would also like to talk about a bit of these all structures. So this was made by Herbert Baker and Edwin Lutyens. Whenever we talk about Delhi, it's also associated with Lutyens. So you have to remember this also, like in planning part or like a city planning, Edwin Lutyens and New Delhi. It goes hand in hand. Okay, talking about Victoria Memorial Complex. This is in Kolkata. If you have ever been to Kolkata as a tourist, you must have visited this place. So sorry. This was designed as a tribute to Queen Victoria when she died. When she was a ruler, when she died, basically the British Empire designed this as a tribute to her. This is basically a museum. This was made by William Emerson. This was basically designed by William Emerson, and this is in the type of Indo-Saracenic architecture. These small things also matter a lot whenever you're studying, because you don't know what kind of questions you can get. So that's why I'm just getting you into the details of all the options also. Coming to Umaid Bhavan Palace, which is in Jodhpur. This was made by Sir Henry Vaughan Lanchester. So this is also very old, and it also has like different features, different like mixed architecture. So it's like colonial architecture, features of colonial architecture. It also has like a Mughal garden. The garden is based on Mughal garden principles. We'll study about Mughal gardens also later. And you come to the last option, Vidhan Sabha Decent, Bangalore. This is in Bangalore. This is made in this Neo-Dravidian style. Neo-Dravidian style, and the architects were B.R. Manikam and Kangal Hanumanthaya. The question also stated about serial vision. So one thing about serial vision, which also like who coined this term, just we have to understand. Serial vision was coined by Gordon Cullen. Gordon Cullen basically, and where else we can see central serial vision, because Rashtrapati Bhavan might not be a viable example. We don't know how it will look right now. So serial vision and the examples, some of the examples are also like in Central Park. Central Park, which is in New York, USA. Basically, serial vision states that you are moving in one line, but you are seeing new things, you are experiencing new things with every turn, with every step, basically. So that's what happens in Rashtrapati Bhavan also. Whenever you're taking the Central Vista Road, the buildings were only visible after you reach a certain limit. So basically, that is serial vision, and yeah, so Central Park, New York, USA is also an example of this. 18th question is of transportation. So this is 2010 question paper where architecture and planning was still like some questions were of architecture, some questions were of planning. When you're studying an architecture course, you don't really study transportation to a very deep limit. You actually don't study at all. I was from architecture, so I know that. But obviously, when you study planning, you have the transportation planning also. So right now, from 2022, they have changed the syllabus, and planning and architecture syllabus has been separated. But questions can come from anywhere, and they have, even this year, even in 2022, they had included a question of transportation in architecture syllabus. So you just have to know a little bit. It's, you don't have to go into the detail. So this question asks, advanced traffic lane information is an important feature of what? So advanced traffic, lane information is actually an important part of intelligent transportation system. I'm not going into the details of this because the questions from transportation do not come in so many details. Question number 19 asks, a local authority can go for urban development through A. Land acquisition, B. Land pooling, C. Transferable development rights, or D. All of the above. So, local authority going for urban development. So basically all the three options and the fourth option is all of the above, so all of the above is correct. And we'll just see a bit about on the what all the options are. Land acquisition, it what happens in land acquisition is that government takes the land from, like, if you own a land and the government wants to make something for development, so government takes the land for the development. And the relocation of owners happens. So if you own a land, if the government needs your land, if through land acquisition government was taking your land and you were being relocated. Relocation of owners. Then land pooling. So basically land pooling was when group of landowners, just write it. So land acquisition and land pooling, what happens that the land in both these cases land is taken for development, but in land acquisition the government takes the land, and in land pooling a group of landowners hand over the land collectively to the government for their development. And in basically here relocation of owners happens, so the land becomes a government owned land, but here the owner remains the same. Next is we have transferable development rights. So basically what this means that it separates the development potential of a part of land and allows its use elsewhere within the defined zones of the city. So what this means is that supposedly you have a plot, and you have a plot and the plot is suitable for basically development, but the government but there's also a risk of developing infrastructure in a city. So basically if you have, coming now to question number 20, it asks the planning document submitted for the selected cities under JNNURM. So JNNURM, basically what it stands for, it stands for Jawaharlal Nehru National Urban Renewal Mission. Urban renewal mission, which means it happens on a city level. So what is the basic what is the kind of planning documents which is submitted? It is city development plan, which is like the perspective and the vision document. perspective and vision document of what the city is and what the people of the city want it to be, and providing strategies and solving, like removing problem areas, basically making infrastructure, making development such as that. So this all comes in the city development plan. Okay, question number 21 asks, excessive tilt of the Leaning Tower of Pisa has been checked by what? So we know about the Leaning Tower of Pisa. Leaning Tower of Pisa. So basically what happened, this is in Italy, and what has happened is that it leans because the foundation because the foundation has settled unevenly. So because it was made a very long time ago, obviously they did not have the different instruments to check the different types of soil present at different depths of the earth. So this is also situated near water body, so that's why the foundation, soil shifted, and then the foundation just was settling down unevenly. But basically this has been controlled or checked by pumping out mud and slurry from the foundation base of the rising side. So you need to remember that it was on the, like, it has been on the rising side. The mud and slurry has been removed. And question number 22 asks, the who has won the Pritzker Prize 2009. So I have just made a video. It's on the channel. The Pritzker Prize from 1979 to 2022. It's all given there, so you can just consult that video. Pritzker Prize, the list is also important because many of the architects which we know, they have won a Pritzker Prize, and it's very nice to know about the buildings also, because it usually comes, the question comes. So coming to 23, the age of a tree is determined by dash. So this is a pretty easy question. The age of a tree, we have studied this in school also, not just in architecture, just in school. So the age of the tree is determined by counting the number of rings in the stem cross section. Stem cross section, which basically means your bark of the tree. This was an easy question. Now question number 24. 24 is Nagakin Capsule Tower, Tokyo, famous for its spatial modular approach, was designed by Ash. So Nagakin Capsule Tower, Tokyo. So this was designed by Kishore Kurokawa. Tokyo and Japan have many buildings which are very very beautiful, very noteworthy, and so this is a very asked question also about like the Tao Ando. Kishore Kurokawa has also been asked many times. Arata Isozaki, Minoru Yamasaki. These are all the options also given, and these have also been asked several times in the previous years. Some more information. This is a residential tower. This is a residential tower. He has also won a Pritzker Prize, so you can see the full picture of Nagakin Capsule Tower, Tokyo, in the Pritzker Prize winners video also. And basically, Kisho Kurokawa also symbolized the concept of metabolism in architecture. This has also been asked in previous year. Metabolism in architecture. So you see, like from one question you can get up to two or three different types of questions. Now, last question of the general architecture questions. 25. Proportioning system used in the layout of Mughal gardens. So proportioning system means how the garden is divided. Proportioning systems in Mughal garden. Mughal garden, as you all know, has a charbagh concept. So charbagh concept. So proportioning system is based on, I'll just read the options. A, rational number system. B, constants of equilateral triangle. C, irrational number system. Or D, constants of right angled isosceles triangle. So in this question the answer is rational number system. Rational number system, like first we have the charbaghs or the four quadrants. The four quadrants, then it's subdivided into quadrants. So it means like four quadrants, then it's divided into 1 by 4. Then this 1 by 4 is also divided into 4 separate, so 1 by 16, and then so on and so forth. And so this is like a rational number, and 1 by 256 is basically um, seen in Taj Mahal's garden. Seen in Taj Mahal's garden. So you can see how much maths and how much basically complicated stuff is used in making such a beautiful garden such as a Mughal garden. Mughal garden also we'll study with examples and stuff in later part also.